Today in Math 30-2, we're looking at Chapter 6, Topic 6.1, Exponential Functions. These are functions that have the form of y equals a times b to the power of x. Exponential functions are either a, increasing, which means they're going to start low next to the x-axis and then move very, very quickly to become very large. Or they're going to be the other way, decreasing, which means they're going to start very large and end up very close to the x-axis. If you take the equation y equals a times b to the power of x, which is the basis of an exponential function, notice it's to the power of x, you're going to see that there's certain characteristics that we're going to follow as we go through this. Now, just to get you introduced today, a can never be equal to 0. B has to be greater than 0. It's not going to be negative. B can also not equal 1. It's going to behave a certain way when it's greater than 0 and less than 1, and when it's greater than 1. We're going to learn about that as we work through the chapter. Now, the number of x-intercepts, well, if you look at this graph, it doesn't appear to ever cross the x-axis. It gets very, very, very close to the x-axis, both in the negative direction for an increasing function and in the positive direction in a decreasing function. However, it never touches it. So the number of x-intercepts is 0. The number of y-intercepts, well, when I look at it, it appears to cross the y-axis once in both of our graphs, so I'd say 1. End behavior. Well, this graph, both graphs start in quadrant 2 and end up in quadrant 1. So we can say that the graphs extend from quadrant 2 to quadrant 1. Well, what else do we notice about these graphs that are the same? Well, let's look at the domain. In both the first graph and the second graph, it appears that it covers all x values. So x, it goes from one end to the other, so x can be any real number. Now, as far as the range goes, that's our y values, it's going to start very close to 0 and go up to infinity, or it's going to start at infinity and end up going very, very close to y equals 0. But in both cases, you can say that y has to be greater than 0. Not equal to 0, just greater than 0, when y is equal to any real number. For homework, I want you to do page 337, numbers 1 to 3, as well as the worksheet that I gave you earlier in class.